A team from Mitsubishi Electric Research Labs, Oxford, and UNC teach a vision language action model to assemble bimanual furniture over long horizons by augmenting every action with a continuous progress signal that trigger the transition, do not wait for it, climb 0 to 1 inside each subtask, and then letting that predicted progress fire the next subtask itself. Average assembly success doubles from 48% to 80%, and the discrete progress ablation collapses to 0, the progress loop. The policy predicts 14 action dimensions, pose and gripper for each arm, plus 1 extra scalar, the progress. Inside subtask k, that progress is I over n subtask k plus 1 over n subtask k times the elapsed fraction of the current primitive, so it climbs monotonically from 0 to 1. At inference, when the predicted progress crosses 0.95, that flags a candidate transition. A persistence filter confirms it, 2 consecutive flags or a recent neighbor. The policy advances, resets progress, and clears its buffers. The transition is learned, not scripted. The problem this solves. A long horizon bimanual task, like assembling an IVAR chair, is a chain of contact-rich subtasks, pick, place, retreat, repeated 7 times. A monolithic policy fine-tuned on the whole trajectory struggles exactly at the boundaries, where one subtask ends and the next begins. Furniturevla decomposes the task into subtasks bounded after each retreat, when the gripper is contact-free, which narrows the within-subtask state distribution. Augmenting the action with continuous progress lets the policy feel where it is inside each subtask and decide when to move on. The backbone is pi 0.5, decoding a chunk of future actions in one pass with flow matching. The proof is in the ablations on tables 1 and 3. Against the monolithic fine-tuned baseline, average success on LACK, CalAX, and IVR rises from 48% to 80%, with LACK at 98, CalAX at 85, and IVR at 56. Now swap the continuous progress signal for a discrete bin. The model collapses to 0 success on all 3 furniture. It gets stuck near completion, where states look visually similar. Keep the continuous signal and scale the demonstrations. 25% gives 50%, 50% gives 68, full data gives 80. Continuous progress is the load-bearing design choice. On the real robot, the cost of long horizons shows directly, 15 rollouts per subtask on the real IVAR chair. Full assembly success falls monotonically from 80% at subtask 1 to 40% at subtask 7. Failures accumulate along the chain, but the per-part success rate tells the other half. Each individual subtask is tractable once the robot reaches it, peaking at 87% at subtask 6. The hard part of long horizon assembly is getting to the right state, not executing the local step. Here is the physical picture. Before, a scatter of flat-pack wooden parts, dowels and panels and brackets, loose and unconnected on the bench. After, an assembled chair, every part mated and aligned, the 2 arms having coordinated across a long sequence of picks and places and retreats. Temporal ensembling, blending overlapping action chunks with exponentially decaying weights, peaks at lambda minus 0.1 across all 3 furniture, beating both the no ensemble default and every positive. The continuous progress signal is exactly what chains those steps together, telling the policy when one subtask is done and the next should begin. Every control and perception design factor was swept on table 2. Lambda. The rear camera beats front-only depth and beats removing the rear view entirely. High resolution, 448, wins everywhere. None of these is a breakthrough alone, but each is a free point of success on a task where every point is expensive to earn. 4 honest caveats. First, the headline 48 to 80% gain is fine-tuned against fine-tuned, the same data without the decomposition. The zero-shot baseline scores 0 but is wildly out of distribution, not the load-bearing comparison. Second, the 16% sim-to-real drop on IVAR bundles, a 5 times cut in demonstrations, 500 in simulation versus 100 on the real robot, so it is not a pure sim-to-real gap. Third, the real numbers rest on only 15 rollouts with no confidence intervals, so the 40% figure is within plausible binomial noise. Fourth, only IVAR was validated real-world. Furniturevla augments a bimanual vision language action policy with a continuous 0 to 1 progress signal that fires subtask transitions at runtime, lifting assembly success from 48 to 80% and cite the continuous progress mechanism, not a deployed system. Trigger the transition, do not wait for it. Staying functional where the discrete progress ablation collapses to 0 while honestly flagging that the real-world result rests on 1 furniture type and 15 rollouts. Subscribe for the next breakdown.